With the population growth, the energy needs and the production of municipal waste resulting are increasing more and more. In one hand, the energy needs are met by fossil fuel in large quantities, which leads to many environmental problems. Hydrogen, however, is a promising green fuel because of its high calorific potential, its renewability, and the non-emission of greenhouse gases. On the other hand, 70% of Morocco's household waste is fermentable and is disposed in uncontrolled landfills. That creates many noticeable problems such as leachate and the contamination of surface and groundwater. Ladies and gentlemen, greetings. My name is Aicha Oujidi and I am going to present to you my research entitled Technical Economic Evaluation of the Potential of Municipal Leachate for Biohydrogen Production in Morocco, Fez area case study. In this research, we tried to analyze the situation of household waste in Morocco and to determine the area to work on in order to study the hydrogen production from the fermentable fraction of household waste and the leachate resulting. Morocco's household waste is dominated by organic matter, which accounts for about 70% of the total weight. The calculation of the household waste production in each region is realized in order to choose our case study area. Also, to know the evolution of our raw material in the coming years. Thus, it is found that the most important potentials are those of Grand Casablanca Stat, Rabat Saleh Kenitra, and Fez Meknes. Also, after taking into consideration these main criteria, the controlled landfill of Fez seems an adapted choice for our study. There are several methods that allow the calculation of leachate production in the landfill. The model chosen in our case is the production estimate using the water balance represented in this formula, and the results are presented in the table below. After the analysis of the composition of the household waste in Morocco as well as of the leachates, it is well noted that our raw material is rather wet and requires a treatment by photofermentation or dark fermentation. It is noted that the landfill of Fez presents production potentialities as well as important loads in organic matter. On the other hand, the absence of chemical analysis of glucose and total organic carbon, which is the basis of hydrogen production from waste under anaerobic conditions, led us to make assumptions on the amount of glucose present in the leachate to facilitate desizing and designs of bioreactors. On the other hand, by comparing the physicochemical parameters of the leachate with the values of hydrogen production, it can be concluded that the leachate of the year 2019 has favorable values of pH, nitrogen and phosphorus for a good production of hydrogen. Moving to the simulation using the SuperPro Designer software that will allow us to see the project feasibility via the different balances. The main substrate at the input of the software is glucose, which represents 2.5% of the initial composition of the leachate. The daily flow of the leachate at the landfill of Fez is estimated at 400 meter cubics per day. The first bioreactor for hydrogen production consists of a dark fermentation from two substrates, glucose and water, according to the following reaction. In order to increase the production of biohydrogen, a photofermentation bioreactor is added. It allows the conversion of fatty acids from dark fermentation into biohydrogen according to the second reaction. And the simulation allows us to produce approximately 400 kilograms per year of biohydrogen. The production of hydrogen from municipal leachate presents a solution to help remedy the energy problems, especially since Morocco has adopted in its national strategy for energy transition hydrogen as an energy carrier. It is also a solution to help remedy the environmental issues, especially to lower the greenhouse gases emission and act to limit the climate change. Finally, I would like to thank the organizing committee of the IRSEC and everyone who made this project possible. Thank you so much.